Hey, good morning, everyone. My name is Ronnie Chatterjee. I'm a senior product manager in the core Azure Data team at Microsoft. So today, I don't have any slides whatsoever. So today is going to be a full demo-packed session. So I was battling internet connections on my laptop for the last few minutes, but glad it worked out. I'm wearing the SQL Server 2019 T-shirt, and somebody asked me that, how did you get this T-shirt? So this was actually given out at the PASS conference yesterday at Seattle. So I just made my way back from PASS yesterday. So I did not bring extras. I did not bring extras, but I'll let the marketing team know that we need some extras. So so today's journey would begin from the ground to the cloud. If you looked at other sessions which we have done for Rohan and Assad, we are taking the SQL Server journey all the way from edge devices to SQL DBs to big data clusters, and all the way into the cloud as well. So, and we store all of this data to precisely do some sort of machine learning or artificial intelligence on top of that data. And in SQL Server, it's a relational database engine with a lot of in-database machine learning capabilities. And today's talk would not be more about building the best scikit-learn model or building the best classifying model, but what you are capable of doing inside the SQL platform in general. So, so in order to get started, I'm going to use Azure Data Studio to be the fundamental tool where I'm going to show the demos. And Azure Data Studio is built on top of VS Code. And we have a lot of extensions which we have used in sort of Azure Data Studio, which you can just go and download and use. One of such extension is the SQL Server Machine Learning Services extension. Don't try to search it right now because this is still very much work in progress. But we are planning to show this in preview sometime later this year. But we could definitely push it into some of the samples repo for you guys to just play around with. Now, if you download that particular extension, you would see a machine learning services tab open up. And I'm going to just probably zoom in a bit for everybody to see. And you can see the machine learning services documentation slide and some of the tasks which we are going to cover, like how you can get started with MLflow, and also some of the machine learning books we publish. So this is the sort of the direction we are heading, is how do we make it very simple for our users to build machine learning-based applications inside SQL Server. So we are going to publish a lot of samples and get you guys off to a start. So now, in this particular samples which I have and which for the notebook, so we are going to start by taking a look at a data set, right? It all starts from the data. And just imagine for a second, you are in the city of Boston, and you want to actually predict the median home price value of the house values depending upon a certain feature set. So, and you have a list of these feature sets: crime, then obviously nitric oxide levels, average number of people staying, and all of that. And the objective is to predict the median home price values. And I chose this data set because it's a very publicly available data set where you could just easily load. And then we are just taking this data set for the entire journey for you. So we are not going to change the data set whatsoever. So the first thing which I have is I am actually going to load the data using just local Python. So if I am a Python developer, and if I want to just use this data set to build a machine learning model, how do I do that? This is not the recommended approach for enterprises. That's the reason I have it written, because imagine this is just the Boston housing data set, but you might have sensitive data in your enterprise, and you don't precisely want to bring the data outside those secure boundaries inside your laptops to do your machine learning model building capabilities, right? You don't want to do that. So this is not the recommended approach, but yet probably 85% of the data scientists in today's world are doing precisely this. And I would like to show that why we fundamentally should not be doing this later on. So I'm going to just load. OK, so my big data. So I'll just connect. Oops. So I'm going to just choose Python 3 here as my connection here. And if you can see that I'm connected just to the local host here, right? So, so in Azure Data Studio notebooks, you have selection of kernels which you can choose from. So in this, I have Python 3, which is my local kernel. And I'm going to just start loading the Boston data set here. So if you load the Boston data set, it's going to load the entire data set, and it comes back as a NumPy array here. And the second step is I'm just going to prepare the data. I'm going to drop the median home price values because that's what my predictor is. And I am actually just taking the training data set. And I built a first very simple linear regression model using scikit-learn. So you can just take scikit-learn and build a linear regression model. As I said, this is not a talk on what best machine learning model to choose. But you see that I could just, in a few lines of code, build my scikit-learn model. And then I choose everything in a predictor variable. And then I can score my model. I can see that my model root mean square error is 0.74, which is not that great. But it gives me an idea of how just to get started with local Python. Now, whenever you're doing local Python, one of the things is people use a lot of packages. People use packages like TensorFlow. People use packages like Keras. People use packages like PyTorch. How do you get those packages inside Azure Data Studio in that context? So we have a Manage Packages option in your right-hand side, where it shows you all of the installed packages you have and all of the add new packages. So now if I have to install any of the packages, I can just search for, say, TensorFlow and search, and it gives me the version. And then you can just click on that version and click install, and it would install the TensorFlow package for you. But then I would like to say, save the model. So now I have built a model. I want to save it. And I want to save it because the person across the aisle who sits, he wants to use the same model which I have built. This is still not the recommended approach, but I'm just showing you guys because what people do normally. So you can save the model, and I've saved a joblib model here. And right now, you can predict for each feature set. I'm just choosing 5 feature set just using that model. And I can see that these are all of the features which went in, and these were the predicted home price values. These are all in the thousands. So in 1970, $30,000 was the house price of the values in Boston. So don't take that this is right now the price of the houses there. So this is how you would actually get started on a local Python and build your machine learning model on any data set. But in SQL Server Big Data Cluster, we have built Spark inside the platform, right? And what does that mean? That means that you can now leverage the computational power of Spark to actually build your machine learning models. So in SQL Server Big Data Cluster, I have files in HDFS as well. And I'm going to use the exact same data set. I'm going to start a Spark session right now. And SpiceSpark is the kernel. So I am actually submitting the Python job using the Spark compute against the big data cluster, which I have already set up. So let's wait a few seconds for the Spark session to come back. And in the meantime, I also have, I'll take a quick look at the Spark session is starting up. And now I have the Boston Housing .csv file, which I have loaded already and is in HDFS. So this is the recommended approach for enterprises, because if you guys are all working on a single unified analytics platform, you can have those files saved in HDFS, and then just all of you can just leverage that file which you have stored to build your machine learning model. So now if I go back to my notebook, I see the Spark session loaded up. And now, similarly, in my session, I would like to install packages, right? I would like to install packages like TensorFlow or Scikit or Keras inside them. And how do I do that? So here is an example of how you just load libraries into the cluster. So I'm just installing a joblib library here because it's just simple. And this is only for the Spark session you're in to actually install that particular library. So I have loaded that particular library. And now let's get started and see how, from using Spark, I can read the files directly from the HDFS location which I just showed. So I'm loading the data from HDFS. And it will give me the top 10 results from the Boston housing data set which we just imported. And it goes exactly the same. So now, once the data is there, I'm going to prepare the data for machine learning purposes, build the same linear regression model from scikit-learn, no surprises there, and then predict what the median home price values are, right? And then once I do that model, I'm actually going to score the model and it sees the same root mean square error. And I could also save the model directly in HDFS. And we are going to go into model management in further in the talk. But now I could actually save my model directly into filename.joblib, which means that this model can now be consumable directly from HDFS, from the guy who is also working with me. They don't have to move models out because your models contain sensitive information of your data. So this is well and good, which is completely Python using the Spark compute. But I'm an R developer. What does the SQL Server 2019 machine learning platform offers me, right? So what we have is we have a Spark R kernel as well. So I'm going to now switch to the Spark R kernel. And you can see that I'm going to make a lot of switches. So this absolutely would mean that my Spark sessions are also going to get restarted every time. But here, I'm actually going to take the same data set and load the model using R to do the machine learning-based predictions. So the first thing we are doing is we're installing a certain set of packages in the cluster. So once this Spark session comes up, we will load the packages, and then we are going to load the library and load the Boston housing data set as well. So, but just imagine that you could have separate, depending upon your familiarity, you can be in different notebooks as well completely. And so now I'm going to load the library, load the Boston housing data set, and quick summary of the data, train and test, and then training our model, and then run predictions on that value as well. And I can see the predicted home price values using R inside SQL Server Big Data Cluster as well. And I am evaluating my model again, and I see a 0.76 of a root mean square error. Now, this is good that I could do my machine learning in whatever language I choose, whether it's R or Python inside my SQL Server Big Data Cluster. Now, the data is all I have built the machine learning model. Now, how do I load this data inside SQL Server? Like, I need to actually still load my data inside SQL Server. So inside SQL Server, what we have done is we have the data loaded from HDFS. But then you could use the Spark to SQL connector to actually write the data directly inside SQL Server. So SQL Server is capable of reading files directly from HDFS. So if you are a SQL developer, and if you would like to have some data from HDFS moved to your SQL instance, you can take benefit of the Spark to SQL connector to do that. If you're working with your counterpart big data team who has a lot of machine learning jobs written in Spark, and they would like to move the data, they could help take leverage of the Spark to SQL connector. So we're going to wait for the session to come up, and then pretty much just writing this particular code, I am actually writing the data directly from Spark to SQL Server. So you can see that I am passing in the database name where I would like to have the database where my data is stored. So now if I go to the Boston data set, expand on the tables, DB of Boston, select top 1000, and you can see that the data came directly from within HDFS instance inside that SQL Server instance where I have just loaded the data, right? This is good. OK, so now, I just don't have data in from Spark to consume. I have data from other data sources. And how do I have SQL Server 2019 as the analytics platform to actually bring data from other data sources? And with this, I would like to share some of the partner engagements which we have done. So some of the partner engagements which we have done is with a company called StreamSets. StreamSets actually provides you with data aggregations from various different data sources. So if you look at the StreamSets, the UI, we have the StreamSets running as a container inside our big data cluster. And this allows you to build actually pipelines. So let me go back and show you what the two pipelines I have. So I have the first pipeline as Twitter stream to Kafka. In this particular pipeline, I'm taking tweets from Twitter, and then I'm creating some tweet records, finding some duplicated tweets, selecting tweet fields, renaming certain fields, and storing it directly into Kafka. This is the first where Kafka is used as a message queue from Twitter to actually store the tweets. And the second one is the second pipeline I have is where I'm actually taking those tweets from Kafka and then storing it directly inside the sentiment score using the Microsoft sentiment analysis and then storing that results inside the big data cluster. So if you have data which you would like to consume from other sets, you could use stream sets to actually move the data inside the big data cluster. So what I'm going to start to do is I'm going to actually start this entire pipeline. Okay. And if I actually run the job, then it should go into my stream sets database in something called Twitter data, or Kafka Twitter, where I have the tables with the streams. So now if I do a select top 1000 on that particular tweet, I should see the data which was coming from Kafka into the tweet store, then pushed into the big data cluster. And also, I have all of the sentiment score, which is also coming from the sentiment analysis. This is the way you could use other forms of data sources to actually move data inside the big data cluster. Now, the other thing which we have done here inside the big data cluster, inside the machine learning capabilities, is we have also partnered with hardware accelerator vendors like InXL, who have built custom FPGAs using Xilinx to actually run machine learning workloads. And one of the things which InXL just recently published was, in order to do an MNIST dataset, which is basically like a handwritten dataset in order to recognize your digits, which is a deep neural net, they got approximately 10x speed up compared to the CPU cores using this particular InXL based FPGA cards from Xilinx. Now, so with that, we have figured out ways of how you can load data inside SQL Server and use various forms of hardware acceleration inside the platform. Now, obviously, package management is a very interesting concept because now you need to install whatever packages you use in your machine learning pipelines to be installed in SQL Server as well. And SQL Server is a relational data store. So how do you do that? So obviously, we have package management built inside our SQL Server core engine. And now I'm going to switch back to a SQL kernel inside Azure Data Studio. And once I do that, I can see the list of available packages which are by default available inside the SQL Server for me to actually use. So you can see that I have Glue, I have Microsoft ML, and I have a bunch of other packages which I have used. We actually can install also custom packages using SQL ML utils, which is basically the package manager, which is also there in PyPy. And if you import SQL ML utils, you can just pass in the name of the package you would like to install. And here in this particular example, I'm just installing the package manager Glue inside the SQL Server. So this package will then be available inside your SQL Server instance. You could also uninstall packages exactly in the same way with package management uninstall as well. So with that, I would like to invite Avrilia Floratu from the Microsoft GSL Labs to talk more on model management in SQL Server and how we are storing models securely in SQL.
Thanks, Ronnie. Yeah, hi everyone. So as Ronnie said, as he showed so far, he showed a bunch of ways we can create models and do machine learning in the big data cluster. So the question is, when we have all these models or different versions of the models, how we can basically compare them, visualize them, and decide which model is best for our use case. So I'm going to show in this part of the demo how we can use MLflow for that purpose. So what is MLflow? MLflow is an open source machine learning model management system. It has a lot of features. Some of the basic ones that I'm going to show here is how you can create experiments in MLflow, which basically means that you can have different experiments creating different versions of the models. Then you can track these models. You can store them in a secure place. You can track the parameters of the models. You can track the accuracy of the models. So, and after that, you can actually visualize the results, and you can compare the models and generate graphs. And then based on all these features, you can decide which model you should eventually deploy. So at Microsoft, we have enhanced MLflow. We are contributing back to MLflow to be able to store machine learning models and their metadata in SQL Server. And this is very important because now we can exploit the capabilities that SQL Server provides related to data security, data governance, and transactional support to sort of store our models in a secure place that multiple users can access. So how can you get MLflow in your big data cluster? So as Ronnie showed before, there is this extension, SQL Server Machine Learning Services. It's not available right now, but it's going to become available soon. And with this extension, sorry.
If you just close the tabs, probably.
Sorry?
Close the tabs at the top, probably. It's on the right.
If you want to just close the tabs here. Oh, okay. Okay, sorry. Okay, yeah, so with this extension, you can bring up this UI. And basically, as you see here, there is an option, Deploy MLflow. If you click that option, we have created a new notebook that you can basically run and deploy MLflow in a container in your big data cluster. And then you can basically use MLflow in the big data cluster through Azure Data Studio. And not this one. Okay, so yeah. So how we can use MLflow? Here in the first cell, I'm going to show how you can import MLflow and how you can set up an experiment in MLflow and then use it to create your machine learning models. So here we just basically import the library. As I said before, we can connect now to SQL Server and store our models in SQL Server. And to do that, we need a database URI. In this line, basically line 16, we are passing as input the URI. We create a new experiment, and then we basically can set our experiment to this one. And after this finishes, we can basically start building a model. As I showed before, we have this URI where we can visualize the results. I'm going to show it now while this is running. Yeah, so the UI of MLflow looks like that. On the left side, you can see the experiments. You can click on the experiments and see all the details about them. Okay, this is taking some time.
Just starting the session, probably.
Okay, it's finished. Okay.
Yeah.
Now we can build a model with MLflow. As I said before, we're going to use SQL Server to store the model. So for this reason, we need PyODBC. This is the way you can install PyODBC on the SQL Server cluster. It's pretty easy. And the next step is basically build the model. This cell is exactly the same as the one that Ronnie showed before to build the exact same scikit-learn model. But we have added 2 lines of code at the end, lines 31 to 33, where basically we use MLflow to log this model in SQL Server. This is simple. You just invoke a log model function, and you pass the model as a parameter. This is going to log your model in SQL Server.
Cross that. Probably cancel this.
This is still working. So the SQL Server instance, you can basically log in any SQL Server. We've picked the one that is in the big data cluster right now, but the code is pretty generic. You can pass any SQL Server instance on the cloud or locally. Okay. And then now I'm going to show you how the model was stored in SQL Server. So we have this table. The MLflow will automatically create a table in your SQL Server instance called artifacts. And then you can query this table and see the models in there and their metadata. So here in that table, as you see, we have 2 models. Each model consists of 3 files. This file, the last one, is basically the actual model, and then the ML model file and the contact YAML file are metadata about the models. They store the different version of the model, what scikit-learn version you used, what Python version, and so on. And at last, you can actually deploy the model to any SQL Server instance, again, using MLflow. Ronnie will show an example of how you deploy that into a SQL Edge. And you can do that through your own code or again through MLflow using the MLflow database deploy command that is provided by the system. I'm not going to run this because it might take some time because the database is external. And with that, I will give that back to Ronnie to discuss the scoring aspect.
So thank you so much, Aurelia. So right now, we have seen that using SQL Server, we could also store our models securely in an enterprise-grade way, so that now the databases not only just has your data, but also has the models stored on top of which was built on top of your data. Now we're going to go into more of the scoring phase of how we score different models inside SQL Server, and that. For the first thing we would do is we're probably going to score the model in Azure SQL Database. And whatever our model we had chosen earlier, we are going to see how to load that model inside Azure SQL Database through MLflow and now natively score it. So, so what I have is I'm going to choose the SQL context as Azure SQL Database. And then I think my notebook went to a state where, with so many switch of kernels, I think I probably just should. I have seen this issue happening, and this is probably a thing which we need to fix, where the notebook sort of loses its connection info after so many switches. So let me just open up that notebook again. Give me 1 second. And now, let's just go back to where it was doing that. So we did model management, and now let's deploy, let's use Azure SQL Database to actually, I don't know why this is erroring out here. Okay, so this is probably something going on in the notebook kernel. So, but what we can do is we can actually have the models loaded inside Azure SQL Database, and then I can use SPIES to actually run this with the R code natively inside Azure SQL Database and run the predictions from the Azure SQL Database running. So the models, once it's built, it can be deployed back inside Azure SQL DB, where I use SPIES to actually run this model, score this model natively against the data which I have already stored in Azure SQL Database. Now, we could obviously do the same thing using Python as well. So where we can choose the SQL Server Big Data Cluster, the SQL instance, where the Big Data Cluster is actually having the model stored. So if I do a select star from MLflow.db artifacts, I can see that this database automatically has the MLflow model. And now I am actually going to take that model and score it inside the database, inside the data, which is there in the SQL Server 2019. So we have scored a model in 2 ways. One is using R, as well as using Python as well. So those are some of the capabilities we have provided across, whether it's in the cloud or whether it's on premises running. The second thing is Azure SQL Database Edge. And you might have heard a lot of announcements of Azure SQL Database Edge, which was recently announced. And this is a very low memory footprint of SQL Server running. So in Azure SQL Database Edge, one of the instances is, since it's actually can be deployed to actually store data from sensor devices, from a lot of IoT-specific data. We decided that in the Boston housing data set, we are going to just take nitrogen oxide because that is the only feature which can probably be just taken from sensors deployed at certain places within the city. So we take the nitrogen oxide and we built the similar, very simple scikit-learn model. And then we convert that model into an ONNX-based format. And now what is ONNX? ONNX is Open Neural Net Exchange format. It's a model packaging format. It's not a framework. But if you have different frameworks like scikit-learn or PyTorch or Keras, you can convert all of these models into an ONNX-based format. The flexibility is now with so many frameworks happening, framework dependency is a challenge. So ONNX is sort of that same unified format which everybody is trying to sort of adopt towards. And so what I could do is I could actually take my scikit-learn model and convert it into an ONNX-based format, and then just run this and test the ONNX model. And I can see that ONNX also has the root mean square error I can get from scoring. So I don't give up on the accuracy of the model even after the conversion inside into the ONNX format. Now I could insert that ONNX model into Azure SQL Database Edge. And I think I'm getting a connection issue here where the connection got dropped. But then in the Azure SQL Database Edge, if I just connect to, you can see that I have the databases where in ONNX, where I have the tables, which has that model which I would like to be, which I have actually deployed back inside the Azure SQL Database Edge. So once this loads up, you can see that the ONNX model which I have trained is actually stored natively inside Azure SQL Database Edge. I also have the data also loaded inside SQL Server. So these are also the features which I have already loaded onto the Edge, because the Edge is capable of natively storing the data as well. Because as real-time data flows in, if you have a pre-built model which is sitting on the Azure SQL Database Edge, you can actually predict on that data in real time with the model which is already sitting on that edge. So with that, let me go back to the notebook and run a native predict on the Azure SQL Database Edge. Now you can see that I have the median home price values also on the edge device, just taking data from the nitrogen oxide levels from the sensors based on the ONNX model which was just deployed. So this is good that we have covered sort of the model scoring, model building, model management, model deployment, storing the data. But what if I would like the model to be a RESTful web service for other people to consume from? How do I do that inside the SQL Server Big Data Cluster? So for that, we have SQL Server Big Data Clusters has the concept of app deploy, where you could actually deploy an application completely natively running inside the big data cluster. And I'm going to actually open up the code which I had. So I have this simple Boston Python script which I had written, which is pretty much just taking the data from the joblib, which is the model.load file. So I am pretty much converting that the model file to a joblib file. And now this model is going to be exposed as a web service for other people to consume from. So in SQL Server Big Data Cluster, let me first connect to the cluster. So we have an extension built on top of VS Code called app deploy, where you just specify the connection to your big data cluster. And here I'm just connecting to the big data cluster. You can see that SQL Server BDC connected on the right-hand side. Once the big data cluster is connected, I'm going to actually deploy the particular app which I have. So it's saying that app is deploying. You can see that the deployed app, probably I've clicked twice. So you can see that the app is deploying, and it would change the state from red to green once the application is completely deployed. Let's see what's going on. App is ready. OK, so now I think I probably clicked it twice or something. So now I have the runspec.yaml file, where now if I just run the app, it's actually going to take the input parameters and actually give me a prediction of what the median home price value is. And you can see that the median home price value is around 29,000 with the data we just flew in. So now that app is running as a container inside the SQL Server big data cluster. So if I go into my output parameters, I can go in and look at the Swagger link. And this would actually give me a Swagger-based JSON response, right? So now my app is running as a container inside the big data cluster. I can just copy-paste the entire Swagger code. And if I just go to Swagger.io, Swagger, clicked on the wrong thing. And now, if I just paste it, I get a Boston ML, the base URL for connecting to this particular app. You can also do actually a post command, and you can see that you can get HTTP web response back from that code. So now that the absolutely the app is running as a part of a web container, I could also generate various different types of clients. I could also convert it, if I am a Python developer, I could actually convert this into a Python-based application and generate Python code, which is absolutely going to download the Python-based package, which I then can use for my Python development. So what we have learned today is we can do model deployment, model management, model training, model scoring with data anywhere. Since this talk was short for 45 minutes, we did not discuss about the data virtualization capabilities of the platform. But in SQL Server Big Data Cluster, you can also virtualize data from various different data sources. Bring data in from all the various sources. If you want to move the data, you can use StreamSys for doing that. You can leverage the acceleration using Spark inside the Big Data Cluster. Build the model, and then deploy the model natively inside SQL Server where the data lies. Do model management with MLflow to store securely the models, compare the models, and then deploy the models back inside SQL Server for doing a native scoring. Or you could expose this as a RESTful web service for other people to consume from, so that end-to-end your model management is taken care of. So with that, I think that brings us to the end of the session. But I would like to leave you guys for a few minutes. If you guys have any questions on the platform, I'll be happy to take at this point. Thank you.